Well, let's start on the first slide. Okay. Welcome everyone. August Great Expectations Meetup. Quick agenda. I realize I didn't update my agenda slide. The agenda is I'm going to do an update on the community and a short one on the product. Don isn't here for the typical product roadmap update, but I have the slides. With that said, make sure you ask your questions in Slack, in the Zoom chat. And if you have any questions about the roadmap, other people from the team will pick it up. We're hiring, so check out jobs.superconductive.com. There's all sorts of great options there. I'm sure some people in here could be excited about one of those jobs, so give them a look. All right, quick update on the community. So the Slack continues to grow. We added 258 people since the last time that we've met. And we're getting really close to 8,000. It's just, I guess it's always around numbers, always fun. So hunt for 8,000 is on. We should definitely be past that by the time we meet up next time. 8,000 strong. The PyPy download. So yeah, we saw the dip last time, and it's sort of gone back on track from where it was before. So we had this huge spike, and now it's sort of found back on the trend that it was earlier. So as opposed to the last month, we had an additional 47K in total. So it's good to see at least it boost up a little bit. Curious what was going on here. Not sure. Okay, favorite part. Thanks and kudos to the community members. So over here we have some recent contributions. We got the new ZenML docs came in. Thanks, Stefan. Bogdan, who's going to be these are both presenters being presented today. Bogdan added the AWS. Oh gosh, I just deleted something. Bogdan added the AWS Glue documentation, and I believe the EMR should be in if it's not already in, but I think Bogdan's going to talk about that later. Yeah, and of course, we have some other additions. Stas Deep, Steven Secreti per usual, and another, Andy Jessen, a whole bunch of the people that we see often here making contributions. So I'm really appreciative of. And then here are Slack supporters. People are answering questions in Slack. Alexi from Provectus has been doing a ton. Veronica, per usual. Bogdan. Kirill, I know, is like a newer member. Thanks so much for, you're asking questions and you're helping people with stuff too. So I appreciate that a lot. We had a new one, Visual Dad. John Schwegler is always in there. Anton, Jared, Juan Yi, Mike Robbins. Dennis, I know, or I'm not sure exactly how to pronounce if it's Dennis or Denise, but another new member is answering questions to really appreciate. Same with these, Ardasha and Andre. So thanks a lot. Kudos to you all for helping out and coming in. You're asking your questions, you're helping others. It's sort of what makes Great Expectations move along. So thanks a lot for your contributions and support. So product roadmap update. We're going to keep this is usually Don's part, so I'm going to try this one out for size myself. So our roadmap is guided with the intent of being able to make the following claim bold and honestly. Great Expectations is powerful and expressive. After years of development and widespread adoption by data practitioners, the core APIs are robust, stable, and thoroughly tested. Best of all, it's easy to get started. So we keep pushing on that piece. We know the easy to get started thing is something that we're actually really focused on right now. And we're gonna have a tranche of work coming up soon that's gonna be focusing exactly on this piece. One thing that we did add recently that I'm really excited about that hopefully helps people get started and find things that they want is we've updated our search. So we're now using Algolia for our search. This will help us learn what people are searching for when they search for something and they don't find it. We can start to see, okay, a lot of people are searching here for something and it's not coming up, or they're not clicking on what it is. Also, this is just a far better experience than the previous search, which I know was terrible. So we have a new search. If you were to do data assistance, you can use the search results page, which is just doc/search. So you could just save this URL to get you quickly to the search page. Okay, yeah, so that's Algolia. Hopefully that helps people find what they need to find in Great Expectations. So moving along, some upcoming launches. If I'm not mistaken, next month, auto-initializing expectations and data assistance with onboarding assistance. I know we're really close on the data assistance that should be coming out soon. Again, if you have questions, put them in the chat. I'm not going to do a great job of answering them as opposed to some of the other people on the core engineering team who are in the Zoom today. So our core focus right now is getting Great Expectations Cloud out. We're looking to create a initial free version that will have parity between open source with the open source platform. It's going to be like a small launch in the beginning. So, people, if you're interested in using the cloud when it comes out, you can sign up for the workshop that's on our site. Also, I think we have a slide later for who to message. If somebody could put Alina's email into the chat real quick, that's somebody who's good to contact if you're interested in becoming a design partner for the cloud platform when it comes out. Because we're going to do limited release in the beginning so that we make sure we're learning as much as we can as we improve the product. Oops. Magic Mouse got me. Yeah, so the V16 release will be shipping in fall. It's going to be smoothing out the onboarding experience, sort of what I was alluding to before. New data connectors, metrics storage, allowing for new use cases for multi-batch expectations and better ways of working with ephemeral data. And then changes are additive and not breaking. So code depreciated in V13 or earlier will be removed. Okay, I got through my section. I'm going to hand it off to our first guest today, and that's Bogdan Volodarskiy from Provectus. Just one thing on Provectus, like they're a consulting group that works in, hopefully I don't butcher this, I'm going off the hip, in data engineering, and they have a strong focus in data quality. We highly recommend them for hands-on services for implementing Great Expectations and helping with data quality. So feel free to connect with Bogdan, and I think Alexi is in here too. You'll see them in the Slack support as well. They're super, super helpful. So yeah, Provectus is excellent. I could recommend them more. So I'll hand it off to you, Bogdan, presenting data quality comparison on AWS Glue and Great Expectations. Updated. This was recently updated to the V3. I copy and pasted the blog. Yeah, it was updated to V3. It was originally V2. So thanks for updating that, and I'll hand it off to you.
Yeah, hey to all. So let me start. Today I will tell you about this theme on my display, but not a lot from a code side, maybe because you can find this in a Great Expectations documentation or in my article, but more about some motivation, approach, and architecture. So let's start. Here on the screen, you see our typical implementation of data quality approach. And first of all, we need to explain why we exactly need to use Glue in this case. Goals our discovery was that Lambda works great, but as a compute engine, yeah. But not well when you work with really big data. So it's related more everyday testing. For example, if you have a new transaction from CDC, if you migrate database to cloud or something like that, or when your database is not so big and each data source file or table is less than 1 gigabyte, and we call this approach continuous data validation. So how you can see, we use here pandas profiling to generate some suits on fly, and great expectation as a data quality tool on a Lambda as a compute engine. And endpoint of this is S3 as a report storage and DynamoDB as a metadata storage. After that, you can visualize, for example, in a QuickSight if you're working with AWS. So, and the challenges, however, if these constraints, I mean, Lambda constraints break, the data quality process will not happen because of pandas memory error. I mean, when you try to read or compute some really big data, if, for example, more than 1 gigabyte, Lambda will show you this error. And no one engine which tries to easily change pandas is not working in that case. I mean, some Dask or something like that. And in this case, when your databases or data lake is big and you want not to set up only daily testing, but to know the quality of your data each time when you want to do it. For example, once per month or once per week. In that case, obviously, you need to analyze all data which is stored at your data source. Also, when we're talking about some ETL processes, after crawling raw data, we often have some transformation step, which may be a catalyzer of a bad data. And we want to test data after every step, each step. So we call this consistency check. It's includes also a step of comparing data. And just imagine how too hard to do it with have to hard to do it for a compute machine with a big amount data. So the answer for all this is Apache Spark. Yeah. And let's deep to data comparison. I saw actually a lot of questions at the Great Expectation community chat about how to compare two data sets and something like that. So here I try to explain same approach which you can find at official Great Expectation documentation, but I came here separately from, I think, Great Expectation team, so terminology may be different. The main idea about that you need to have some golden data set, we call it producer. For example, in ETL pipelines terminology, it may be raw data, and generate test based on it, then run against on it. And after that, you can run these tests against your target data set, for example, transformer data. So, I mean, you run the same test to both data sources, consumer and producer. After that, you can also run some comparison tool if you want to see some additional information. And to have access to all reports, after that steps, you need to implement some metadata storage in a BI dashboard. Sure, also you can implement some logic to notify someone if they not compare after test run. I mean, data sets. Yeah. This is how our real project implemented solution looks like, I need to mention some little agenda about this project, and some ML engineers spent a lot of time using pandas, but when data is grow too much and the computer machines could not calculate all necessary things for acceptable time, then they rewrite all the algorithms using Apache Spark engine. But they weren't sure how it works, good or bad, and they come to us with the idea that they want to use pandas as a golden data set and Spark as a target. And the goal was to compare quality. So it's a typical case of our producer consumer approach. And you see this pipeline on the screen. So short explaining, on the first step, we run some profiler. You can use pandas profiling or native Great Expectation profiler also. I think now it's good. We also try to use it. Then you generate these tests on some golden data sets, how I said before, on fly in that case. Then you profile your Spark data frame. You also can use the both tools as a pandas profiling or Great Expectation native, and run this prepared or cooked test on a new data set. And after that, we also run a great tool as a data compile. Just a couple of words about that. It's some comparison open source tool, which can show you all necessary information about scheme, changing data types, and row counts. We use this for, how I said, for additional information besides just data quality count, to know the root of the problem if it happens. Here you can see just typical reports. It's data compile. And after that, we decided to discover some new opportunity for using Spark and Great Expectation. And I need to tell why. How I understand, it's using MRR, it's more suitable to data quality approach, because as AWS recommended to use Glue to more analytics work, not for computing, but MR it's more about computing. And as a result, MR cheaper than Glue. So you see here on the screen the reference architecture, how it looks like and how we can use it, how we can implement. It's a new feature, MR serverless. So you don't, it allows not to waste so much time to launch clusters and etc. It works with the same as a Glue principle, app, compute, and down. You don't lose money for idle state too. Unfortunately, for creating the same pipeline as you can create with Glue, not so easy, because I don't know why, but they not implemented this serverless MR to step functions pipeline yet. And now we need to invest some new way here. I don't want to read from slides all steps, so it's just you need to use from Lambda bota-free library to call MR serverless job and tagged with some task token. If you're familiar with step functions in Lambda, you should understand what I'm talking about. And after that, just to subscribe to Event Bridge. All this thing, I think, for Great Expectation integration with MR serverless already in the documentation, how guys said, so you can read and try to do it to yourself. Also, last thing I want to talk about, at Prolectus, we released some Terraform module, which deploy all necessary infrastructure with Lambda, S3, and DynamoDB it's built on top of Great Expectation. So architecture you can see on the second slide, this one. So it's already will deployed by one click with a Terraform module, and you can start your data quality in your new projects. Yeah, so I think it's short demo. That's all for today, and I hope you will have some questions for me. A little bit nervous.
Great job, Bogdan. That was excellent. And do you have these slides hosted, or maybe I could download them and host them. We'll make sure that people can, because these are great slides that people can.
Yeah, I will share with you after.
Sure. Yeah, and I'll attach them to the video and share them out with people after. Really cool. I saw data compies by the Capital One group, which is interesting. Seems like they do a lot of open source work, which is cool. I wonder, yeah, if we can do something with that project. Could you say again, what was the piece of that for why to use data compi?
Some clients want to see, so not in that way. I need to formulate. Clients come to us and said, hey, I want to compare our data sets. Mm-hmm. And they don't understand that it's very hard to run a big, real big data and compute it. So this data compile allows to you run it very simple and with Spark Engine, and they just print you some short information, short description about your data sets comparing, and it's very native, I think. So with Great Expectation, we take a data quality, and with data compile some other information.
Very cool. Yeah, really interested in that. Does anyone else have any other questions? And also feel free to use the chat as well. If not, or does anyone have any questions? Okay. All right. Thanks so much, Bogdan. Again, definitely check out Provectus if you need more hands-on work with implementing Great Expectations. They're really great. Keep putting out awesome content about Great Expectations. Okay, cool. All right, we will move on to Hamza, who will be talking about ZenML and how to use it with Great Expectations.
All right, perfect. Thanks, Kyle. Everyone can hear me well? Like, Kyle, maybe a thumbs up? Okay, all right.
Yep, you're good.
All right, cheers. I'm gonna share my screen. So here it is. All right. I only have one screen, so it's gonna have to have our pictures on it. I hope that's fine. Or is that fine, like, Kyle, or should I share like just a window for the recording?
Yeah, I mean, whatever works for you.
No, this
works. I can't actually, we can't see the Zoom stuff if that's what you're talking about.
All right, perfect. Cool. Okay, so let me start with an introduction. So I'm Hamza, one of the co-founders of ZenML, and I guess the good place to start, it would be, what is ZenML for the Great Expectations community? ZenML is a MLOps framework that allows you to create modular and portable ML pipelines. The way we like to describe it is, we like to say that ZenML is a three-step process. So you integrate your tools, you author your workflows, and then you orchestrate them anywhere. And while it looks like a pipelining tool, similar to Glue or like what we just saw, or also like other famous pipelining tools like Airflow or Dagster now, or Kubeflow, it's really not an orchestration tool. ZenML is more like something that sits on top of the orchestrators and lets you write these pipelines which are machine learning specific, and then you can run on any orchestrator of your choice. If you wanted to run on Glue, if you wanted to run on Kubeflow, Airflow, like some of these we have out of the box with ZenML, but you could also add your own. So you could like create a portable pipeline that just defines your business logic, your machine learning specific logic, and then where it runs depends on what we call the ZenML stack. So the first step is usually to create a pipeline. You can see this in this visualization. The way to create a pipeline, I'll show you in a second. You just annotate some functions, some Python functions with the add step. Then you create a stack. This is a second step. So you have to create where and how the pipeline runs in what we call a stack. And a stack has the orchestrator, the artifacts where they should be stored, feature stores, experiment trackers, model deployers, and importantly for this meeting, data validators. And these, like this is sort of done outside of the workflow. So you just do this once and then you share it across with your team. And then finally, you can build your own stuff as well. But if you just want to use the standard ones or you just want to extend it, extend the framework, you can. And then you combine the pipeline and the stack together, and the pipeline runs on the stack of your choice. So that's the theory. I want to jump straight into the demo because we've been working very hard to create different sorts of stack components, as you might imagine, because we live in the world of abstractions. We are in a lot of ways a standardized way of writing machine learning pipelines. And one of the biggest assets or aspects which we were missing a month ago before we started working with tools like Great Expectations was this notion of a data validation component. So we had orchestration, we had deployment, we had experiment tracking, but a lot of our users came to us and said, hey, what if I want to detect drift, or what if I want to check my data quality as data flows through the pipeline? And therefore, we started looking at Great Expectations because that was the most obvious first choice. And when we looked into Great Expectations, eventually we ended up integrating Great Expectations in a way where we like to think of it as you create ZenML pipelines and you continuously validate your data using Great Expectations. So it's sort of a continuous process, like just like what we saw before, but ZenML takes care of a lot of the heavy lifting for you. And it does things which complement the Great Expectations offering quite well. And let's see how it works. So for this, you need to first understand what the stack is going to look like. So we're going to create two pipelines today. We're going to create a profiling pipeline, and we're going to create a validation pipeline. We're going to talk about each of these individually, but these pipelines are going to run on a Great Expectation stack that I've set up. A stack in the ZenML world has three components that you need to define for sure. So one is who is actually executing it. So the orchestrator. For now, I've chosen the local orchestrator, but you can also have the same demo on Kubeflow or Airflow or Glue automatically just by switching this component. There's another metadata store. So this is mislabeled. This should be metadata store, which is basically the tracking database of all these pipelines. And then we have the artifact store, which is that things that go in and out of pipeline steps, where are they stored? In this case, I've chosen S3, but you could choose any cloud provider. And the fourth component that I've added to it is the data validator, which is the Great Expectations data validator. How do you set that up in code? So the way you do that is you just have to run these commands. So like ZenML allows you to register these individual stack components on the command line. So the first thing I'll have to do is I'll have to create an artifact store. So I can just do this for one. You can see, okay, this is successfully registered. I've given it a flavor and I've given it a path. So this will now store everything running in the pipeline in this bucket. If, by the way, I ever wanted to see all of my artifact stores, I could look at them. So you can see I have two here. One is my local one and one is my S3 one. I'll quickly do the data validator as well. So now I have my artifact store and I want to register my grade expectations data validator. This is also very simple. ZenML data validator register. You give it a name and then you give it the flavor. And there are some parameters that are extra. I've used the default sane defaults, but you can configure your grade expectations through these commands. And you just have to do this once. And then the next command, what it does is it actually registers an S3 stack. Well, I gave it the name S3 stack. This is the thing that you see here. And I'm using the metadata store to be the default one. I'm using the orchestration to be default. And then I'm just going to add the artifact store, the one that I just registered. And I'm going to add my data validation, the one that I just registered as well. And then I'm going to set this stack to be active. So that's the first step you have to do. This is a bit ZenML heavy, but it's a bit of a, like we have to go through this step, one configuration step in order to hook things up. And then you get a lot of power out of that. So by the way, once this stack is set, you would be able to list all your stacks. So if you have many other grade expectations or buckets, like different sorts of stacks, you could share them across your team like this, but that's something for later. Right now, my current active stack is the one that I just created. All right, now let's start creating my pipeline after I've created my stack. Just going to do some imports. What I'm going to do is I'm going to create two pipelines, as I said. One pipeline is going to profile a data automatically. So for that, I need some data, right? So what I'm going to do here is I'm going to use the breast cancer data set, which is a simple tabular data set that everybody's probably familiar with. I'm going to return that in my first step, which I call the importer. And you can see that ZenML works in Python. So this is basically a simple Python function decorated with a special step annotation. And then the next step that I have to create is going to be slightly different. Here, I'm going to use my two big new steps that we've introduced with this integration. It's the grade expectations profiler step and the grade expectations validator step. These two steps are doing different things. The profiler step is actually profiling a data set and creating an expectation suite based on the auto profiling that comes built in with grade expectations. The next step is taking an expectation suite name and a data set, and it's actually computing the expectation data docs. So those are the two steps that come built in with ZenML. All you have to do is import them and instantiate them here. By the way, I'm doing all of this in a notebook. We encourage you to do this in scripts, but it's a bit easier to illustrate. All right. And then the next step, what I'm going to do is I will get a checkpoint result, which is a result of a grade expectations validation sweep. And I'm going to use this to actually print out if my expectation was successful or not. The reason I've added this step is I wanted to show that ZenML has made it easy to actually pass results of grade expectations suites and checkpoints between steps. So that's a very powerful thing, which I'll show you in a second. So these are the steps I need. And now I need to put these steps together in a pipeline. So that's quite simple. The first one I'm going to do is the profiling pipeline that just has two steps. It's going to import the data and it's going to profile it using the profiler. The second step is equally simple. I have the importer step, I have the validator step, and then I have the checker step, which takes the result of the validation. And you can see this is also quite simple Python. I won't go much into detail, but it's basically saying, hey, this function returns two things. One thing goes to this function, the other thing goes to that function. It's a bit like a Keras model. Cool. So after all that is done, we actually need to create a run. So you can think of these pipelines as recipes, which are abstract. And we now need to plug in our concrete steps into our pipelines. So that's what I'm going to do. Won't go into the weeds here, but I'm just going to run these two pipelines. And what's happening now is it's using the S3 stack. So because it's using the S3 stack, it's actually running this pipeline locally, but it's storing the results in S3. So if I go over to my S3 bucket, I could, right now I have 4, but if I refresh, I should be able to see 5 things. I don't know which one it was. And here, this is my stack unique ID, right? So if I saw my stack's unique ID, I would be able to see it. And here you can see that all my expectations and checkpoints are automatically tracked for you. So you don't need to do anything. You just need to call that step and it works automatically or automagically. The first pipeline, what it's doing is it's just taking this data frame and it's just profiling it and creating an expectation suite. And this is I just printed out the expectation suite. And the second pipeline, it's actually taking that same expectation suite and running it through that data frame. And then crucially, it's storing that result in S3. So now that these 2 pipelines are almost done, so the validation failed in this case because I split up the data and we overfit on the data, but it doesn't really matter. What's important is that I could fetch the result of that in my downstream step, even though this was not in memory. So even though the result was not remaining in memory anymore, I could fetch it back. And that's very important. So what do I mean? So if I, for example, in the future, if my teammate or someone else wanted to actually see where my result was of this particular pipeline, so let's say the first pipeline, I could simply use my simple ZenML syntax to get my pipeline, get the latest run of my pipeline, and get the step which produced the profile. And you can see that this will result in a simple step view, which shows you that actually the grid expectations profiler step is the step that we're looking for. If you look at the outputs of that step, you can even see where that step has stored the actual suite. And if I wanted, I could probably read it. I'm not sure if this works so great, but yes, you can even read it straight into your notebook. So you can have your expectation materialized for you, and ZenML handles that as well. This is even cooler, I think, with the second pipeline. So just quickly, and you can see that the second pipeline has, I believe, yeah, only one output, and I can read that. And this is actually in result, right? So this, I imagine this is a this is a great expectation. So thing which, so like you can fetch it, but you can't print it in a notebook. So I can fetch it in a variable. And then I can, yeah, I mean, there are many variables associated with it. I think status was one. I'm not sure, but yeah, it's a checkpoint result. So maybe one of the great expectation guys will help me. If I look into my, it's my it's dot success. Yes, that's what I want to show. So I can see, for example, that this is a failed validation result. So I can, in memory, quickly query, no matter if I ran this pipeline a year ago, the versioning of the data docs is done automatically. Just to make this a bit more visual, ZenML has a way to visualize these pipelines locally. I mean, if you run on Kubeflow or Airflow, that they're already visualized, but we also have a local visualizer. And you can see this is the first pipeline. And here you can see, for example, that the data set is stored here in S3. The expectation suite name is breast cancer suite, and it's stored here. And if I wanted to see, for example, my second pipeline, that looks a bit like this. So it would also look very similar to this. And what's really interesting is we also have a built-in visualizer, which actually visualizes the data docs for you directly. So you can actually materialize your data docs locally with this visualizer that we've built, which is basically using the visualizer that Great Expectations already has. And the fun thing is that the run name of the suite is the same as the pipeline run name. So you have a complete lineage between your pipeline runs. I mean, you could be doing a lot in your pipeline, right? You might be deploying a model after this. You might be doing some experiment tracking, and having like a centralized metadata store like ZenML to track these pipelines is quite cool. All right, so, and then, I mean, maybe I can also run this quickly. Yeah, so there is, for example, the second pipeline. And like the last thing I wanted to show you guys was that if I, for example, run my pipeline again, so let's say I ran my validation pipeline again, and let's say this is like a downstream step that happens like a week later or something. Like ZenML obviously will track those new results as well. But what it will also do is the depth of this integration is that we have actually created a data context in Great Expectations terms that links the notion of a ZenML artifact store to the Great Expectations data context. And what that means is like by coupling these concepts together, if I was to go to my data docs again, excuse me for a second, I'll just run that visualized results again. This will open up my data docs again. But if I go here, you will see that actually it's not a separate data docs that is lying somewhere else. It's actually together already. So my validation results are also coupled together with my pipeline runs. And my expectation suite is just the same suite that we had. So we have a complete lineage and we have a complete merging of our concepts with this one neat tool that lets you write these pipelines. And by the way, you can run these pipelines on whatever you want. You would have complete data versioning and data lineage of the entire expectation suite and the results. So yeah, that's the presentation I wanted to make. I hope I'm not over time. Just a few quick links for you guys. Maybe someone can pop it in the chat. We have a blog post that explains all this. ZenML sets up Great Expectations. To go into further details, we were also very happy to have now official Great Expectations reference architecture for ZenML inside the Great Expectations docs themselves. So you can also read that. It's pretty much a bit more a Great Expectations view of these things. And if you wanted to try it out yourself, I encourage you to go to our repository at zenml-io/ZenML on GitHub. And we have the Great Expectations data validation example that I just showed you, which basically does the exact same thing or a variation of that. And yeah, I look forward that you guys run these pipelines in production and hopefully it's very useful.
Thanks, Hamza. That was awesome. Really like the UX for the CLI. Just a heads up, I just noticed that we've been having problems with Netlify's hosting our docs, so those might be. I'm really happy that you already had that link up for the docs because I just tried to open it and there was an issue. So I guess everyone just be patient. Be patient with that.
No worries.
I see Tanner has his hand raised. Tanner, if you're still there and have a question, you can let it rip.
I don't. Apparently, I mashed the raise hand button, but that was a great presentation. Thank you.
Thanks, Tanner.
Thanks, Tanner.
Does anyone else have any questions?
I'd be interested to hear also the Great Expectations team's opinion on it, or maybe anyone else in the community, because it's very new. And from the ZenML perspective, we work together with you guys, Kyle, as you know. And I'd be very interested if there's a use case that we could find. If someone immediately finds it useful, if you could pop it in the chat, it would give some sort of validation for the work that's been done.
Yeah, definitely. And I think we should, now that we'll be presenting this, we'll do some follow-up with the community and seeing who's using it and find some early adopters. So if anyone in here is going to start experimenting with ZenML, definitely let us know so we can get some feedback and then even help you get started. So we can start learning more about how this integration is helping you all.
Awesome.
Cool.
Cheers, Kyle.
All right. Thanks so much, Hamza. All right. We have reached the end. I think I mentioned earlier, that bit about cloud. I see Ben is here, who it's now a tradition for me to put him on the spot in the community meetups. But like I said, if you're interested in becoming an early user, Ben actually is a great person to chat with if you see him on Slack. And then Ben, if you want to say more.
Thanks. Thanks, Kyle, for putting me on the spot. Yeah, fun to be here. Just reach out to me if you'd like to learn more about our cloud product. We're getting pretty excited about what we've got going on over there. So anyway, great to see everyone. That was awesome. I really want to play around with ZenML this weekend now. So
Yeah, definitely do that, Ben. I think you'd give some great feedback. Cool.
And join our Slack community if you want. So we have, it would be great to have you
Yes.
on the weekend.
Yeah, get in there and mix it up. Cool. All right. Well, thanks everyone. See you next month.
Later all.
Bye.